Morning guys, today we're going to take a look at page 11 of the Unit 8 Classwork packet. The shape we're going to look at today is a rhombus. So on the left side of your Classwork pocket, or wherever you happen to be writing down these notes, oh my god, what is that? Anyway, wherever you happen to be writing down these notes, I want you to draw me a picture of a rhombus, alright? What we're going to do is as we go through the properties that make a rhombus, I want to actually visualize them in a diagram. So the first thing that makes a rhombus is that its diagonals are, does anybody remember what that symbol means? That symbol means perpendicular. So what I would do, guys, is I would draw my diagonals like so, and then where they meet, I would draw 90-degree angles. That's going to be important because notice that creates 4 right triangles all over the place. Hint, hint, nudge, nudge, that's going to mean the Pythagorean theorem is going to come back quite frequently in order to torment you some more. So I apologize for that, but there's no getting around it. All right, property number 2 is the one that everybody knows, right? That rhombi, plural of rhombus, rhombi have 4 congruent sides. The way I'm going to show that in a diagram is to simply put tick marks all around. All right. Last but not least, the diagonals, not only are they perpendicular, but they happen to be angle bisectors as well. Let me show this, okay? Diagonals are angle bisectors. What does that mean in the context of a diagram? Well, it means that this right here is going to split this angle into 2 equal parts. Notice I use the same tick marks because these opposite angles are congruent. And then this one is going to split each of these angles into 2 congruent parts. Okay? So, just like the case with the rectangle, remember that a rhombus does inherit everything that belongs to a parallelogram. For example, it also has 2 pair of opposite congruent sides, 2 pair of opposite parallel sides, opposite angles that are congruent, diagonals that bisect each other, blah, 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 right? So just make sure you don't lose sight of that. Because all rhombi are also parallelograms, all those characteristics that apply to parallelograms will carry through to the rhombus as well. Okay, with that being said, let's take a look at 2 examples of what this might look like on a unit test. So we're going to start off with example number 2. All right, let me draw this rhombus. I know it's a bad rhombus. I apologize. We've already been through this multiple times before. I am not an artist, okay? So just cut me a little slack here. All right, so first things first, let me actually write the information they gave me, okay? So they actually gave me EF, which is 23, and they also gave me DF, which is 40. So this whole thing here, maybe I should use a different color, but oh well. All right, that whole thing is 40. Now, what I'm going to do is I'm actually going to put some of that information they told me, or that I know rather, because it's a rhombus, on the diagram. So I know that rhombi have 4 congruent sides. So I'm going to put those tick marks right there. I also know that rhombi have diagonals that are perpendicular. I could write in that angle bisector information too, but from the looks of this problem, I'm not going to need it because they don't ask me anything about the angles. Okay, so because all 4 sides are congruent, I actually know that each one of these sides is 23, which is kind of nice, right? Now, this whole diagonal here happens to be 40. What does a diagonal do? What do the diagonals do to each other? They bisect. Right? So that means that this piece of the diagonal is 20, and this is also 20. Okay? Let's stop there for a second and see how much of our information we actually know. Do we know GF? Yes, we do. It is 20. Do we know HF? Where HF. Did I mislabel something? Oh, I'm sorry. I'm sorry. Blah. This is GF. Shame on me. I can't read. So GF is 23. This should be H. HF is 20. Let's talk about GH. Okay, I actually don't know that one, so I'm going to leave that for right now. And do I know GE? No. So I know half of my answers, which means I can get at least half points on this super, super, super simple problem. All right? Now, in order to find this missing piece right here, here's what I got to remember. Do you guys all agree with me that there is a right triangle right here? Let me redraw that for you. Right triangle, this is 23 and this is 20, okay? What theorem can I use with right triangles to find a third side? The Pythagorean theorem. So I have a leg and a hypotenuse, so I'm going to do 20 squared plus b squared equals 23 squared. That's going to mean that 400 plus b squared equals, I want to say that's 529. Don't quote me on that. Is it? Yeah, I'm going to go with that. I'm going to subtract 400 from both sides, and I get b squared equals 129, and b equals rad 129. All right, let me actually just make sure 23 times 23 is, I'm not losing my mind, 0, 6, 4, 9, 2, yes, I'm right. Okay, so rad 129 would be this piece, but this piece is also rad 129, so the whole thing would be how many rad 129s? 2. So GH is rad 129, and GE would just be 2 rad 129 because it's twice as long. So notice, part of this problem was easy because all it relied on was us simply realizing that 4 sides were congruent and that the diagonals bisected each other. The other parts were a little bit more involved because we had to use the Pythagorean theorem to find unknown side lengths. All right. Now, the second example we're going to take a look at is example number 4, which instead of dealing with sides, deals with angles instead. So let's have a little look at how example 4 would work. All right? All right. Oh my goodness. All right. 2 diagonals. Okay. Now, they give me some information here. So this is 38. Yeah, and that's all they give me. Okay, so the nice thing about dealing with rhombi is that I don't really need all that much information to figure every single thing out. And here's why. Notice that because it's a rhombus, that means that I have perpendicular diagonals, right? So in the middle there, that means angle 8 is 90 degrees, as is every angle in the middle. Now, rhombi also have a special property where their diagonals are angle bisectors. So this, and this are all the same measure. So if this is 38, so is this, so is this, and so is this. Oh my God, isn't that wonderful? Then, okay, from there, I need to remember something about triangles. How many degrees are there inside a triangle? 180, right? So I've used up 90 here. That leaves 90 degrees, right? And I've used up another 38. So how many degrees are left for over here? So I would do 180 minus 90, which is 90, and 90 minus 38, which I think is going to give me 52. Let me check that. 52. And guess what? Because angle bisectors, right? Because the diagonals are angle bisectors, 52, 52, 52, and 52. All right? So in a rhombus, angle problems may actually be somewhat simpler to solve than pure side problems, all right? There's a little bit less math, but still, you will have to remember the special property of the rhombus, which is that the diagonals are angle bisectors, and you also have to remember triangle sum theorem, which is that there are 180 degrees inside a triangle.